Hi, this is Rummana Bari. I'm going to present our work titled Detecting Stressful Social Interaction Using Wearable Physiological and Inertial Sensor. This work was done at NIH Center of Excellence for Mobile Sensor Data to Knowledge in the University of Memphis. Who does not have stress in their day-to-day life? Everybody is encountering different sources of stress in their daily life, and it can negatively affect our behavior, our feelings, our relationship with others, and reduces the productivity and quality of life. And if we want to manage the stress, first we need to identify what are the sources of stress. There can be numerous reasons of stress. It can due to work deadline or some exam or maybe some financial situation. So studies show that social interaction is one of the biggest stressors in our day-to-day life. And in our work, we are focusing on stress due to social interaction. If somebody is aware of his stress during an interaction, he can feel more control of his response and know when it's time to take a break and de-stress. Smartphone and wearable devices has the capacity to monitor the stress dynamics passively in our day-to-day life. And this can be used to manage the stress through some timely intervention, like just-in-time intervention. So there are numerous ways of intervention. Some requires active attention and some can be performed passively. So depending on what is the stressor, one can choose from this pool of intervention. So for example, for stressful interaction, it may be more appropriate to choose something that does not affect the flow of the conversation. So for that, the device needs to know which stress is happening due to stressful interaction. So our goal is to determine stressful social interaction. And here we are proposing a method to detect the social interaction directly from the stress time series data. And our stress arousal show distinct pattern depending on different types of sources of stress. For modeling, we have faced several technical challenges. First one is the lack of annotated stress, even in the field environment. And people traditionally use diary-based method, interview-based method, but they have their own limitations of temporal precision issue, or they contain subjective bias. So we need a reliable method to annotate the stress even in the real world. And there is no model that detects stressful interaction from the physiological or inertial sensor. So we need to develop novel features to do that. To handle the first challenge of annotation of stress event in real life, we have developed a day reconstruction method-based stress visualization where stress is depicted through a timeline diagram with other context of location, conversation, and activity. So when a stress arousal is happening, the user can recall what happened during that time, looking at other channels of information. And this stress time series is computed from a field-validated stress model, and the color code is showing different intensity of stress. Now, to capture the stressful event in field, we ran a study and we recruited romantic couples so that we can maximize the number of interaction. And they were chest band sensor, wristband, and smartphone. After completing the data collection, we show their data through the contextualized visualization, and they annotate those higher stress arousal with the reason of stress. So now we have a continuous stress likelihood time series data, and it is annotated with start and end time of the stress events. Now, if we look at the stress arousal during a stress event, we see cyclical pattern. So our goal is to identify its stress cycle so that we can compute several morphological features from that. And its a stress cycle contains several points: stress rising point, saturation point, decay point, and the recovery point. We develop an algorithm that identifies all the interesting points, and the performance algorithm is 96% in field. Now we have able to look at its cycle. Now we are able to compute several features like rising duration, falling duration, and amplitude. We also interested to see what happens in our wrist motion during a stressful interaction, and we saw energy is higher during stressful interaction compared to other sources of stress like commute or work-related stress. Now, our goal is to detect whether a stress cycle is happening due to stressful interaction or other stress like work or commute. And we train a random forest classifier and F1 score is 0.74 using stress cycle feature. When we combine wrist motion features, the F1 score increased to 0.83. Now let's see an application of this model. In case of just-in-time stress intervention, if we observe one cycle and we then intervene, so we can provide a quicker intervention, but F1 score is 0.74. If we wait longer than one cycle, for example, 2 cycles, so the F1 score is improved. So we need to make a trade-off between the duration of intervention and performance of the model. So now in summary, we have in this paper, for the first time, we have shown a way to detect stressful interaction from the stress time series data and propose the idea of stress cycle and develop several novel features. We also utilized the day reconstruction-based method visualization to annotate the stress event reliably in field. Thank you so much for listening.